Hi, this is Mr. Beckstrom, and today we're going to take a look at an example problem from the homework 11.1. It says solve the system of equations. If the system has no solution, say that it is inconsistent. I apologize for all the background noise. So I have these two equations here, and I want to find a solution if possible. If not, I want to say that it's inconsistent. Now, when we're talking about two linear equations like this, a solution is where those two lines cross, right? So if we were to graph those like this, it's going to be the point at where they cross. So there's only going to be one kind of situation where we have no solutions at all. And that's going to be when those two lines are parallel. Because when they're parallel, we're not going to have any solutions. And the only other option here is if it's both the same line. And if it's both the same line, then you're going to have an infinite number of solutions because there's going to be an infinite number of points where that those two lines have in common. So this is the conceptual idea behind what we're doing here. So let me go ahead and get rid of those lines. Now, let's go back to this one. Now, we should have a couple of different methods in order to solve these. The one that I usually like to use, if possible, is elimination by addition. It seems to be a little bit easier. So that's what I'm going to do here. And this problem is already set up to do that. So before I write the equations down, I want to see if I add these equations together, I want to eliminate one of these variables. And I can already see that this is set up for me. So if I add these two equations together, 5x and minus 5x, or plus of negative 5x, is equal to 0. So it's already set up. Now, if it was not set up, I could multiply an equation, or even both equations, by a constant in order to get it to work. And we'll, I'm sure, do one of those pretty soon. But in this case, if I just add these two equations together, so 5x minus 3y is equal to 14. I'm going to add that to the second equation, negative 5x minus 3y is equal to 10. So add those two up here, and I'm going to get, 14 plus 10 is 24. Negative 3y plus a negative 3y is negative 6y. And 5x plus negative 5x is 0. So our new equation is actually negative 6y is equal to 24. And the reason that we're going to do this is because we want to get down to just one variable. Because if we get down to just one variable, then we can solve for that variable. So in this case, if we divide both sides by a negative 6, we're going to get y is equal to 24 divided by a negative 6 is negative 4. So that's going to be our y. Now, the next thing is, how do we get our x? Well, we can get our x by putting this negative 4 into either one of these equations up here and then solving for x. So I can either use the first or the second. I'm going to go ahead and use the first, but you can use the second just as easy. So I'm going to say 5x minus 3, and we know that y is equal to negative 4, so I'm going to replace the y with a negative 4, and that is equal to 14. I'm just using this first equation up here. So now 5x minus and a minus is a positive. 3 times 4 is 12, so plus 12 is equal to 14. Subtract 12 from both sides, and we're going to get 5x is equal to 2. And finally, if we divide both sides by 5 to get the x by itself, so that means x is equal to 2 over 5. All right, so we have y is equal to negative 4, and x is equal to 2/5. So that's your solution for this problem. It is not inconsistent because we have a unique solution. That means these two lines are not parallel. All right. If you have any questions, let me know, and I hope you have a great rest of your day. Thanks.